All right, everybody. So we're going to do something called the distance point to a line. Algebraically, it might be the most intimidating thing you see first semester, but I think we'll be okay, and with practice, it does get easier. So the goal here is to find the distance from the point 3,8 to the line y equals negative 3x, negative 3/4 x plus 4. So a lot of times, I'll just draw a quick sketch. So negative 3/4 x plus 4. So I know for sure that because this is the y-intercept, so this point here would have to be 0, 4. And it's a negative slope, so it's going down to the right. And we're trying to find the distance from the point 3,8. So I'm just kind of ballparking it. There's no perfect science to this. And even though it just says distance, it's actually implied to be the perpendicular distance. So I don't have to say perpendicular for it to be assumed perpendicular. And we're trying to find, I'll call this D for distance. So the challenging part is that, well, we kind of do have like x sub 1 and y sub 1. But I don't really know this point here. As soon as I knew that point, that would be x sub 2, y sub 2. So the challenge is, well, how do we find the coordinates of that point? Because I can't really use the distance formula. Just to remind you, is distance equals x sub 2 minus x sub 1. I can't really use this until I have both coordinate points. All right, so you kind of have to think in terms of systems. So what I'm going to do is I'm going to graph a line. You can see I'm not the best on notability, so bear with me here. And that blue line is going to actually contain that red line. So if two lines are perpendicular, recall that they have opposite reciprocal slopes. So we know a point on that blue line is 3,8. And the perpendicular slope to negative 3/4, it's going to reciprocate, and the opposite of a negative is positive. So if I write the equation of that line, point-slope form is the best way to go. Which, again, doesn't really help me. I'm trying to find the intersection, this yellow point right here. So whenever you are trying to find where two lines intersect, you're really trying to find a system, or solve for a system. So the first equation is negative 3/4 x plus 4. And I'll be honest, point-slope form in a system, not the most ideal. So let's go ahead and distribute. So that's y minus 8 equals 4/3 x. All right, so 4 times negative 3 is negative 12, divided by 3 is negative 4. And if I add the 8 over, my recommendation would be to do substitution. So you could sub in for y. However, there is a hack for this particular one. It's just a fortunate coincidence that if you look carefully, these are both in slope-intercept form, and they have the same y-intercept. So it's not that I did a terrible job drawing the first time, but actually what I can do is say that this goes there. Let me erase. So again, it was just the ballpark, but now we have more clarity as to where they intersect. So if I can avoid substitution, especially with fractions, I'm going to. So the answer here is 0, 4 for where they intersect. Let me move this to Oh gosh, this is why Mr. Ursay usually doesn't use notability. Oh geez, okay. Thanks for being patient with me. Alright, so now that yellow point, we're more interested in this one here. So we can use the distance formula, which is up here in purple. So we're trying to find the distance now from 0, 4 to 3, 8. So I'm just going to sub in my value. So again, you can do 3 minus 0 or 0 minus 3. So 3 minus 0, x minus x squared plus y minus y squared. It's pretty forgiving. The order does not matter. So 3 squared is 9. 8 minus 4 is 4. 4 squared is 16. And the square root of 25 is 5. So let's put units. Tomorrow in class, I'm going to show you a shortcut because I'll be honest in that this is the correct answer. It's just not the most efficient way of doing it. So I'll show you a way that hopefully speeds things up. But conceptually, I just need to make sure you have an idea of what it is we're looking for. We're still talking about distance, and I'll see you in class tomorrow.